All right, so this is the scene that we're going to do our research and development on, okay? And it's exactly what you probably already have or should have at this point, which is a bullet scene that something gets demolished. And what we want to do to this scene is to add our stuff to it. Now we could go into your scene, but just in case you didn't have your scene or something was different, I wanted everyone to be on the same page, okay? Just like everything dynamic, it's really going to depend on your scene scale and your specific assignment as to how these things play out. So having everyone start at the same spot gives it a little bit easier way to introduce some of this stuff, okay?
One piece is going crazy.
One piece is going crazy. I don't care about that piece. Because my camera angle, if I was going to shoot this, would be like this. I don't even see that piece. Okay, or I would have cuts here and there, whatever. All right. Anytime you do anything dynamic, it's best to kind of go into a clean scene, play with the dynamics, and then jump into your other scene and then try to apply that. Because it's very difficult for you to go into your scene that has a whole bunch of stuff going on and trying to get this stuff to work. Okay. So you've set your project to this. You've opened it up. So just set your project if you haven't. File, set project, building knockdown, and then go to open up the only file in there, which is building knockdown debris startup. And what we want to do is two things. One, we want to add some sort of trail to that ball coming in. So the ball's not just like flying through the air and hits the thing, but there's actually like a debris trail. There's like, if it's a meteor, there's a big flame basically emitting from it and flying behind it, okay? So we could do this using particles, using strictly particles and just going into here and playing with this, but the particle system isn't as nice as FluidEffect, okay? If you go to the visor, you don't have to go to the visor, I'm going to show it. But if you go to the visor under the FluidEffect assets, these are all different kinds of fluid. Those aren't the kind of fluid effects. Where's the fluid ones? Fluid examples. There we go. These are all different things you can do with fluid effects. Okay, so it's not just for explosion smoke stuff like that. You could actually do clouds, which is they actually look like clouds. Here are some explosions that you can do. Here is fire. Here are liquids. And again, they're not really showing up good. Okay, so you can do some liquids. The liquid simulation is not really for liquid simulation. It's more for like artistic-y type things. Here's some miscellaneous things. The smoke that's inside here. Here's some space things, and then here's some random technique things. Okay, so you can play with those. You look at them, explore them. FluidEffect is a monster within itself. Typically, I go right into particles, and then we deal with particles, and then we work with that for a little while. But I want to get right into FluidEffect because there's so much stuff that we can use FluidEffect for to make things look realistic. So what we're going to do is the way it works is particles. If you remember when we created the particle volume around our building and we emitted particles, okay, so that volume is just like where it emits from, and they just kind of shoot out and go anywhere. Fluid effects are contained. So we have to create a container for where this smoke is going to be. So we're just going to go up to fluid effects and we're going to create a 3D container. Okay, so create a 3D container and we're not going to scale it. Okay, we're just going to move it out into the middle area-ish. All right, so create a 3D fluid container and move it, don't scale it, to the middle-ish. All right. Now, we never want to scale the fluid effect container. When we start scaling it, we start losing quality. If you were able to watch the video for the Bifrost at least, one of the things we mentioned is that there's these things called voxels. Okay, if you have a picture of something like this and you zoomed up really, really close on that picture, you would see these tiny little pixels, right? We know what pixels are. Well, voxels are 3D pixels. Okay, it's basically like a little container for all of these little bits of data that are going around. So the second we start scaling this, we're stretching those areas out, meaning that our fluid effect is going to be scaled out. Okay, So what we have to do is we have to tell Maya to automatically scale this out for us, and it'll keep all of these things nice and square. Okay. So if I look at this, just so you can see, these little squares represent the voxels. Doing that stretches out the voxels. We don't want that. Okay. So we're going to hit Control A. Mine's over here. There it is. Okay. And when we open the attribute editor, it allows us to go to the fluid shape and change the size. Okay. So the X direction is what we want to do. So you could type in numbers. Here's a quick way to make a slider is you hold the Control key and you middle mouse button drag on that X for the size, and it'll automatically start resizing it. Okay, so we're gonna go, I think it was like maybe it was like 200. There we go. So now I'm just resizing this to fit what I need this to fit. Okay, so I'm just gonna set this to 30, 30, and 200. Okay, I'm essentially just creating that path for where this is gonna come in. Let's set to 240 and 30. That should be good. Okay, so resize yours and reposition it so that we're basically enclosing this. Think of this as an aquarium, and we want that ball to go into the aquarium so that we have nice little particles flying through it. Okay, good. All right. Now you'll notice that we have in here we have these bigger blocks, and they look like this kind of stretched out, but they're not. However Maya figures it out, they're not stretched out. Okay. And I'm surprised I rewound it. I thought it would automatically resize those. Sometimes it does, and sometimes it don't. So, all right. So if we hit play, you don't have to hit play, but if we hit play, you'll see that nothing happens. Okay. Right now, all we have is a container. That's it. There's nothing else happening inside the container. It's just a container. So we have to tell Maya that we want the ball to emit smoke and emit fire and emit this fluid effect. So we grab the container, we shift click the ball, and we go to Fluid Effects, Add Edit Contents, Emit from Object. Okay, grab both, Add Edit Content, and then Emit from Object. Okay, so now if we were to hit play, we'll see a very dusty haze inside of our box. Okay, because these voxels right now are so big, it's basically just like a big particle, big particle, big particle, and then it's blending between these huge particles. So we need the particles to be a bit smaller so that they blend together a little bit nicer. Okay, so we're going to click on the box again and change our resolution to 60. That'll be a good number to start with. And then when we rewind, you'll see now that our voxels are square. And then we hit play, you'll see that now we can actually see a streak going across. Okay? Now this streak, what's happening with this is, imagine the aquarium. That sphere is flying through the aquarium and just leaving particles along that aquarium. Okay? Once they're out there, then whatever's happening inside the aquarium is going to happen to those particles. So if we said, okay, well, there's a lot of gravity in the aquarium, so we can set that smoke cloud to fall down. Or we can say there's not a lot of gravity, it actually should be going up. Or we can say just start dispersing because the particles are really loose and they can just start disintegrating, okay? So this number here, we want to keep that as low as possible right now, and then when we go further on and we're ready to render, then we might take this up to something ridiculous like 200 or 300 or whatever, okay? Depending on what you're trying to get. When you have the flames, like a flamethrower, and you have those like licks of flame happening, that number is super high and the simulation time is super long. All right, so we're going to leave it the way it is for now. We're going to scroll down to where it says temperature, and we're just going to change this to dynamic grid. Okay, so change your temperature to dynamic grid. What this is doing is when the ball is emitting, it's emitting density it's emitting velocity, and it's emitting temperature, okay? And what this does is it just gives different properties to that little smoke trail here that we can manipulate later. That's all that's doing. We can also turn fuel on, but we don't need to turn fuel on, okay? So we're just going to scroll down. We're going to leave a lot of this at default now. We'll come back and change these. Just to show you, if I scroll down to this grid interpolation, I change it to Hermite, just as one click, and rewind it and play it, you can see how much slower this one change is making this simulation, okay? So that's why we typically wait until the end to start turning these settings up, just so we can get a little bit quicker playback, and then we can start tweaking things.
What does Hermite mean?
I have no idea. It's how it's basically going from grid to grid, from voxel to voxel. Linear is just like a straight movement, and Hermite is some sort of formula that does it a little bit differently, okay? So we're going to go down to content details and then density. And that brings up a good point. There are so many definitions inside here that that it helps to have the Maya help going and actually have like the fluid thing up on the side, simulation and effects, fluid effects, and have this kind of off to the side so that if you are like, I don't know what this tool does or the setting does, you can look up the definition really quick, okay? You could even hover your mouse over here, and if you're lucky, usually it shows it, come on. Usually it shows it. It'll give you a little definition, a little blurb about what that specific thing will do, okay? If you've ever seen any videos on doing fluid effects, usually it's this. Change this to this, 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 and now we have fire. Okay? We can't do that. We can't learn like that. All right. So I'm going to do my best to give you the definitions of these, or my interpretation of what the definition is, and then we'll go from there. Okay. So if we look at this, right now what we're seeing is the density. Okay, we're seeing that thickness of that smoke. If we come to the density and I start dragging this up, you can see how I can scale up and down that density. Okay. I also have properties like buoyancy. Buoyancy is its ability to float. If we played it, and you watch mine, and we just let it go for a little bit, you'll see that it's gradually moving up. Okay? That's just the buoyancy of 1 just gradually moves this thing upwards. And it's also being counterbalanced, if we scroll up, by the gravity. So gravity's pulling it down, buoyancy's pushing it up, and so we get this kind of lofty movement. If I take gravity away, you'll see that it doesn't do anything. Let me take my buoyancy down. There we go. It's very odd. It should be going up higher than it is, or faster than it is. I don't know why it's not working as quickly as it is. We'll just ignore that and move on. All right. The next one, which is dissipation. This is as the particles and as our density is out there, how quickly it's disintegrating. Okay. So think of like when someone blows smoke. There's like this big dark cloud of smoke, and then as it goes out into the room, it just kind of disintegrates. Okay. That's dissipation. All right. And you get a better result with dissipation than you do diffusion. Diffusion is typically just kind of like, it's hard to explain, but it's like the drop off of that coloring, where dissipation is actually like it breaking away and hiding. Okay? So if we take the dissipation up to 1 and then we play it, you'll see that now we're getting that thing kind of fading a bit more. But it's not just like fading, it's actually like disintegrating where those particles are dying off. I think what I need to do is add some more resolution up here. I'm going to add it to 100. Let's see how slow this goes. That's not too bad. Okay, take your resolution up to 100 and take your dissipation up to 1. Okay, that way we're dissipating, but we still have some resolution out there. Okay, some of these don't need to be recalculated. Like I can't see dissipation unless I rewind it and then play it again. But this density scale, I can just click and drag and see what that density scale is doing, okay? And even though we can't see what's happening in this entire box, this specific area here we can see, but there's a whole bunch of stuff happening all the way around this, okay? Even though we might not be able to see that there's particles right here, sometimes there's actually particles there. And when we start grabbing this density scale and pulling it up, sometimes we'll actually see some of those things that we can't see otherwise. All right. So there's density, pressure. Here's some noise. So I'm gonna add a little bit of noise to this, like 0.15 to the noise. Okay. And what this does is it just adds a little bit of noise to the density, so we don't have just like a flat white cloud going across. That we actually have that density kind of broken up. So add a little 0.15 to your noise. Okay. Now it's still kind of boring. Okay, this little smoke trail going across is pretty boring. So open up the velocity and turbulence, and we could add things like swirl. So just for fun, take swirl up to like 5, and then rewind it and play. Play reframe. All right, I'm not getting the same results I would like to get. We're going to go up to the top, and we're going to force the simulation to be a bit better. That way we'll probably see a lot of these things that we're not seeing. So scroll up to display and change your voxel quality to better. Okay, up to under display it'll say voxel quality better. And then scroll down to where it says high detail solve and say all grids. And I think we might even need a little bit more particles in here. I think that might also be the problem, where we're not really getting a whole lot of stuff happening. On the very top, there's a fluid emitter 1, so we're going to click on that. And here's the rate. This is how many particles are actually being shot out of this ball. So let's take it up to 200 for the rate. So we just click on this emitter up top and change our rate to 200. I'm just running through my list of things. There we go. All right, so I added a little bit of noise in there too, and that seems to have broken it up some. So you can go back to the fluid shape, go to the noise tab, and add a little bit of noise, and that will help break it up that that shape a little bit more. Okay, so now we're starting to actually shape what this is looking like and trying to shape what this result is. As we're doing anything like this, you typically want to have some sort of reference. So, meteor images. So we could look at something like this and try to emulate even something like that happening. Having that picture really helps kind of understand the movement of it. Because what you don't want to happen is that it looks too soft. Like this is 170 frames. Let's rewind it and play it again. There, that's about a second. Okay, so in about a second, how much movement should we have in the smoke. If this thing is flying through space, it wouldn't be dissipating that fast. It wouldn't be doing breaking apart that quickly. So that's where we can take it and sort of slow things down, take the swirl down, take the noise down, and play with those kinds of settings. Okay, for now we're just going to leave it just because it gives us an idea of what's happening. Also, if we look at this and it just let it go until it gets a little bit bigger, you'll see that this box is starting to fill up. Okay, this container is actually a container. So our smoke is coming out and it's butting up against the sides and it's butting up against the top and bottom and butting up against that other area. So if we didn't want that to happen, but we still wanted that smoke to do what it's doing, we would have to either, one, make the box bigger so we don't see it, or we would have to go under here, way at the top, and change these boundaries. Okay? Right now it's saying it's basically butting up against all these sides, so we could take these boundaries off. So set your boundaries to none, and what would happen is now they're going to shoot out, and it's just going to go, and once it hits the edge, it'll just disappear. Okay? Alright, so we're not really seeing it butt up against it. It's literally just going out of the box and going away forever. Alright? So in some cases you don't want that, some cases you do. In this case it's fine. In other cases, instead of it colliding with an object, you can actually use that boundary to say, you know, I want to shoot fire at this box and just let it just shoot at it, but I'm using a boundary and it's looking like it's hitting it but not really hitting it. All right. So then we can come down here to turbulence, and we can also add some turbulence to that mix also. Okay, swirl is doing exactly what swirl sounds like it's going to be doing. It's like twisting it. Okay, turbulence is just a noise pattern. It's just like moving it randomly. So I'm going to take my swirl down to like 2. I'm going to take my turbulence down to maybe 0.1. My noise down to 0.2. There we go. So I think that's probably a good pattern for this thing to be, you know, coming in and hitting the building. So again, my swirl's at 2, my noise is 0.2, and my strength on the turbulence is 0.1. Okay? Now if we look a little bit further down, here's temperature scale. I adjust temperature scale and nothing happens. Okay? Something is happening, we're just not seeing it. Just like I said, there's other stuff happening inside here that we just can't see. Temperature is one of those things that right now we just can't see stuff happening. So we're going to scroll down to where it says shading. This is where we'll be able to see what is happening to temperature. Inside shading, this is where you really control what this looks like. So if we jump back to our picture here, and we're looking at this, just based on this image of what we're looking at, I'm going to guess, I'm going to assume that the very core of this thing has the most density and the most temperature. Okay? That's where all the action is happening right there. So right at that core, that's where this is really bright. There's bright yellows and oranges and maybe a white inside there. As it dissipates and it basically the fuel is burning off, the temperature is reducing, and the smoke out here is kind of dissipating out into nothingness. Okay? Inside Maya, this is where we tell it that we want that to happen. Okay? So these sliders here are not just like, you know, regular sliders, I want it to be this color or that color, but it's actually reading stuff like the temperature and the density, and it's coloring it based on the temperature and the density. So if we go to the color area and we just change the color to black, you'll see that this thing changes color. Okay? It doesn't just change it to black. On mine, it actually made it like, you can't really see on the screen, it made it like a red in the middle and then a black on the outside. Okay? So change yours, hit play, and see what color it turns out to be. Alright, so now this color information basically is saying just color the whole thing black. The color I want is black, but I want to get the color from somewhere else. And that's where incandescence is coming in. Okay? When it was set to white, it's basically adding white on top of the incandescence, so we couldn't see it. So now that it's black, it's adding black to the incandescence, so now we can see the incandescence because Black has a value of 0 in computer technology, and white has a value of 1. So here we can manipulate these colors to change how this thing is portraying. Okay, so if we look at this and we just start messing around with these colors here, I can get different results. I can really push maybe the yellow here. There we go, and push the orange there. So now you can see we have the yellow right at the core, the orange is a little bit further out, and then we have the black. And if I manipulate this further, I can probably push that black into that. So now it's not really high res right now, but now it looks like there's a big fire right here and little bitty sparks flying along that trail. Okay? Now we can also, I hate to have stuff bunched up here, but we can also kind of separate and spread this out a little bit. Okay? So I can spread this out, and I can use this little slider on the bottom. And the slider on the bottom basically pushes my graph, or pushes that temperature to one side or the other. So if I push it this way, you'll see that I'm starting to get more of the oranges right inside here. And as I push it the other way, I'm starting to get the oranges going the other side. Okay, and the yellows that way. All right. I could also, now that we're doing this based on temperature, that's where the incandescence is being read from, is temperature. If I change this to density, now it's reading the density. It's saying how dense is this area here, and then going with that. Okay, so we're going to leave it at temperature because that's what we want, and I'm going to leave it at 0 where that was. But now we're going to come up to our temperature scale, and you'll see now the temperature scale is going to work. Okay, because we're actually using temperature for something, now we'll have a scale that we can manipulate. So temperature also has a dissipation. So what I want to do is I want to dissipate the temperature. This chair out of my way. I want to dissipate the temperature around here, and then the rest is left to density. Okay. So what that should do is it should keep a very hot core, and then basically the rest of this should be just softer coloring. Okay. It should be that density, that dark color, whatever we set that color to be. All right, so I'm going to take the dissipation up on temperature to, let's say, 1. We'll just start at 1 and try that. And then we rewind it and play it again and see what we get. Okay, so in mine, you'll see that that's pretty much what I get. I get a hot core, and then on the rest of this is just black. And then I can come down to, I can obviously go to my temperature scale and adjust it. I can also come down here to my incandescence and adjust my graph or move these around. There we go, something like that. Okay, so adjust it until you get something that looks similar to that, where we have this yellow and red here, yellow and orange here, and then it just gradually trickles back into that blackness. Okay, so this is what FluidEffect boils down to, is trying to manipulate what kind of data we have basically with these fluids, and then how we can push our stuff to look the way we want it to look. So even when you look at, weird. Let's try that again. When you look at something like this, and we're seeing this really hot core here, we're seeing the smoke out here, and we're seeing that other stuff, it is doable to create something like that within FluidEffect and make it react the same way. But we have to understand what's happening in there. We have to understand that that core is super hot, super dense, and then it's just dissipating and moving out. Okay.
It could be FluidEffect, actually. I don't think that's an actual picture of a meteorite.
Right, it could be. Yeah, there's no.
I know
it's probably a Michael Moore or a Michael. Yeah. All right. So now this is still pretty low resolution. Okay. Well, again, we're just keeping it low res for now, and then we'll up the resolution at the end. All right. So now we also have opacity, and this is one that's always kind of got me, even when I'm playing with this. Typically, it's doing the same kind of thing. We're using density here, and we have a graph and we can, you know, manipulate it. But typically, like if you watch any tutorials, they usually take that away and then they make this little like shark fin pattern in here just so you can see. Something like that. And then you can play with this and then you'll get some, you know, pretty neat effects at some point. All right. Well, that doesn't work for me. So what I do is I just go in here and just kind of manipulate what this is doing with the density. And I'm just looking off on my image here, and I'm looking at my other one. The biggest thing that we have to keep in mind is that we can't make it too dark. If I make this black, like totally black, you can't see any detail to it. So my goal in this is to add some noise to it, basically, just some randomness, to kind of soften some of these things, and then utilize this to help control how big this thing is. Okay, so I typically create a graph like this, just basically like a little hill, a plateau, and then I use my little input bias to control how that's looking. You can see I can go, there it is, look at that. Really insane, and make this really puffed up with smoke, or I can pull it back down. I could also change this to be based on temperature and change it to like that, okay? So for now, just change it to temperature, set it to a little graph like this, and adjust it until you get this little smoke trail like that. All right, so this is essentially it. For this guy, this little meteor, that's what we're doing, okay? So let's run through all the changes we made just to get to where we're at. We took the base resolution up to 100. We made sure our size obviously fit within there. Now if you saw that the ball shoots through this and then just disappears, that might be a good way to kind of transition where the ball is no longer emitting a fire. But if you wanted the ball to hold out a little longer, it's just a matter of moving the box. If we move the box over, make it a little bigger, it'll encase that ball. But what we don't want is the ball to just sit here like it's on fire for an hour and a half. Okay. We took the boundaries off. That way we're not getting anything. What would happen otherwise is the smoke comes up, and then just like in, you know, if you have smoking a cigarette in a short room, the smoke goes up to the roof and then it kind of wraps around. Okay. We added the dynamic grid to the density, velocity, and temperature. We changed our voxel quality to better. We left that alone. We could add a little damping in here too. That always helps. I'll just add a little bit now. We changed our high detail solve to all grids. That's good there. Took the density scale up a little bit. Again, all of these settings we could change after the fact. We changed the buoyancy, we changed the dissipation, added a little noise, added a little velocity and turbulence. We took the temperature up a little bit, added some dissipation to that as well. And then we came down to our color, made the color black, adjusted the incandescence to look like that, adjusted it to the temperature, and then adjusted the opacity to the temperature and got that. Okay. So that gets us this result, and that looks pretty good. Now you could also do another fluid effect right on top of it. Okay, so we could actually have 6 fluid effects happening at the same time. But each fluid container, this box here, this is what that box looks like. So I can't have that box look like 16 different things. I can have it look like this, and that's it. Okay. I can go up here to where I have presets, and I could save that preset. So if I know that, hey, I love the way that fireball looks, I want to save it so I can use it again later or use it on something else. Like if you set it up inside your test scene, save the preset, go into your new scene, load the preset, you're pretty much almost there. Okay? You still have to do some things, but pretty much you're almost there.
Save some preferences.
Yes, it'll actually save the preset. So if you say save preset and I say cool meteor, and then I were to create a new 3D container that has nothing on it, I can go to that 3D container and say cool meteor replace, and now I get that cool meteor shape right there. Now it doesn't change everything. It didn't change my resolution because that's really scene dependent. Okay, if you have a huge scene, you might need more. If you have a smaller scene, less. Okay.
That saves to your 2015 X64.
No. It saves it to that folder, yes.
Okay.
But it doesn't save you those preferences anywhere. This is just saving an extra preset to it. Okay. So I had to change that. I still could create an object. I could just make another sphere. And I could tell that sphere to emit from the object. And then when I hit play, you'll see that now we get a little meteor ball. It's not doing anything really because there's no gravity or anything really pushing it up too much. But if I took this and just animated it real quick, there we go. You'll see that we're getting pretty much the same animation on there. Okay? But just taking that preset and applying it to something new. So at a studio, that's typically what they have, is they already have like cool flames, and they have smoke, and they have oil smoke, and they have, you know, all this stuff. All right, so there's that guy. Okay. Now we could also take this, and once we're ready, we could up the resolution, just so you can see how long it's going to take. I'm going to save, just to make sure, and then hit play, and you'll see again nothing super fast. It's again one of those things where we're just constantly waiting for this to happen. All right, and actually I'm getting these funky little smoke rings inside here. That's where I could come in and change my slices per voxel to a bigger number, and possibly even take my grid interpolator and put that up to Hermite. And again, all those steps are going to make this take even longer. Okay, but again, it'll look nicer. So for now, I hit escape. All right. So for now, I'm going to leave it at the default settings, and what I'm going to do is I'm going to click this disable evaluation button. Okay, I rewind it first, click disable evaluation, and what that means is that it's no longer going to calculate. Okay? So as I work with other dynamic things and I get those other things set up, I can just ignore it basically. Okay? That one's good for now. I'm going to do the big building here, and that one's going to be set up a different way. Okay? So we hit play, nothing happens. Okay? So what we're going to do is just hide that. Make a new layer and hide that fluid effect. Okay, the building is actually a bit trickier. Our goal when we animate this building is that we want it to emit some sort of smoke or debris as the pieces are falling. I don't want them to emit right now. Nothing's happening right now. Nothing's collided with it. There's no reason to have smoke and debris and whatever else emitting. If I create a thing, so just create a new 3D container, do the same thing to resize it, use the attribute editor and the control key. And this is going to be pretty big. We don't want to just encase it here. This building's going to fall into the water, so we have to make sure it covers that whole ground. The other way. Okay, and you can always change this later too. If you realize, whoops, I didn't go far enough, you can make it bigger. Okay, so I did mine 90, 45, and 60. I always like to round them. The easier we make the math for Maya, the less likely we are to crash. Okay. So now that we have this enclosure here, if I were to take the pieces, so grab your building, shift-click your box, and go to Fluid Effects, add Edit, and then Emit from Object. And then just for fun, you can hit play and see the madness ensue. Okay, so we don't want that to happen. We don't want the building to just be, the ball hasn't even hit it yet, and it's already emitting some sort of smoke on it. So what we want to do is we want to control this a little bit more. We want to be able to tell Maya, or to have Maya figure out for us at what point we want the smoke to happen. Now we could, if this was, as easy as, grab this. If this was as easy as on and off, we could actually tell it to, don't emit anything. And then we'll wait for the ball to hit right about there. And then we can keyframe that on. But you'll see how this just looks funky. Like all of a sudden the building's emitting stuff. Okay? It doesn't look like it's emitting the way it should be emitting. Also, as these pieces start are landing, the ones that stop moving should not have any stuff emitting from them. Right now, as it sits, they would be. Okay? A building or a rock just sitting there with this thing turned on would still be emitting some sort of smoke. So we have to do a little bit of black magic on this and do a little bit of trickery. So there is that. So what we're going to do is, if I can remember where the button is, we're going to go to the outliner. We're going to open up our building, and we're going to delete the fluid emitter. Okay? That's how you remove something from being an emitter. So we went to the outliner, we opened up the building solved, and we deleted that emitter from it. Okay? So now it's no longer emitting. If we were to hit play, we would see no more smoke inside of our building. So what we have to do is we are going to emit particles. This is going to sound crazy. We're going to emit particles from the building, and then as the building falls, we can read how fast each particle is moving, and then we can say, if you're moving this fast, emit this many particles. If you're emitting or moving this slow, don't emit any. Sounds crazy, but it does work. Okay? So we're going to go to the building, and we're going to say particles emit from object. Okay? So now the building is emitting particles. It's not emitting anything else. Okay? It's just particles are popping out of the building. Okay? So if we rewound it and played, our playback would go super slow, but our building will look like it's getting a bit fuzzy. Okay? Is everyone's building getting fuzzy? Okay. So we're going to rewind it again. And the reason it's, number one, going slow, and number two is getting fuzzy, is because at each vertice on the building, it's basically an emitter. So it's emitting, right now it's set to 100, it's emitting 100 particles per second from each vertex on this building. That's why it's going super slow. So if we change this type to surface, let me make sure it's right before we go further. Yes, it's right. We change this type to a surface emitter, you'll see that we no longer go super slow. Okay? Now a surface emitter allows us to emit particles basically from the entire surface and not just the individual points. Okay? So right now this 100 is emitting 100 particles per second for the entire building. All right? So before we had, let's say, 1,000 points, we had 100 particles per second per point. So it's like a million or jillion points. So we're going to take this rate up to like 500. Okay? So now they're emitting particles, and they're just kind of sitting there. We need a way to figure out how to take these particles and stick them to the building. Okay? That process is called a goal. Basically, we tell the particles, hey particles, you guys need to be stuck to the building. That's your goal. Try to maintain that shape. Okay? So we rewind again. We grab the particles. We control click the building. I'm using the outliner because it's easier to select stuff in there. And we go to particles goal. Okay? So now when we rewind and play, you'll actually see them kind of buzzing around. Okay? Your particles are freaking out. And the reason they're freaking out is because right now, if I go and grab the particles again, and I go to their particle shape, and I scroll down to the goal area, the goal is set to 0.5. Basically, it means do whatever you can to get there, but I'm not in any hurry for you to get there. Okay? If I set this to 1, it means go there as quick as possible and stay there. It's like when you ground your kid. You know, don't take a detour to your room, just get there.
How'd you set the goal?
You just grab the particles and go to their goal weight, and you just set that up to 1. Okay, so as you can see now, as we hit play, that we have particles being emitted, and they're sticking to the building and moving with it. Okay. Okay. Now again, we're keeping this low resolution for now. Eventually, we're going to up the resolution. Okay. We're emitting 500 particles per second, and they're just randomly going over this entire cube. So you can see how some of these pieces, like this guy, has no particles on him, where this guy has a whole bunch of particles on him. Okay? So in the world of Pixar and ILM and all this stuff, they can write super duper scripts that actually figure out this piece has 17 particles on it. I only want to use one of these, or I only want to use whatever. They can write super advanced scripts. We're not going to get that crazy with it. All right? So we're just going to keep it really low res with these particles on here now. Once we're a little bit further and closer to being done, we can actually take this 500 and make it 5,000, and then we'll have 5,000 particles on there covering more pieces, making it look a little bit more realistic. Okay? Just so you can see how we'll be able to cover more pieces, I'm just going to rewind this and play it again, and you'll see how now the building is being covered, kind of like Christmas lights, with particles. Okay? So, but we're keeping it on the low side for now. As much as we can, we keep it on that low side. Okay? All right. So what we need to do now is we need to tell these particles to emit, or to be the emitter for the fluid effect. So again, we'll use the outliner. And I grab the particles, and I control-click the fluid, and I do that same add edit contents under the fluid effect, emit from object. We need to grab the particles, grab the fluid, so we have them both selected. Then under fluid effects, add edit contents, emit from object. Okay, and now our particles are the emitter. Okay, wherever our particles are, they're going to start emitting into our container. All right, so now again, they're just kind of emitting as they're alive. So the second the particle pops into the box, it just starts emitting stuff. So we're going to turn on a feature called per particle emission. Okay? I think it's per particle emission. That's the right name. Per point emission rates. So we just grab the particle, and then under the particle tab, we go to per point emission rates. Okay? Nothing fancy is going to happen on the surface. What that gives us, oops, it's already open, is in our particle shape, it gives us this little guy here. Fluid emitter 3 rate pp per particle. Okay? So that's all it's doing. And if I hit play, I will probably have nothing happen, which I don't. Okay? Because right now it's not reading any emission from any of the particles, because each particle has their own emission rate. Before, as a whole, they were all emitting 100 or 200 or whatever it was per, or 100 per particle. Okay. So now what we have to do is we have to read how fast each particle is moving, and then use that number and assign it to the emission rate. Okay. So who knows how to do that? We do this. We Google it. And what is up with my screen? So I'm just going to copy this so we can read it in something else. Or notepad. New, paste. Okay. So we're going to use this little script here, okay? And what we do is anything in particles, and this is the cool thing about them, you can assign expressions to or little mini scripts to them. Typically, anything math related we can do, okay? So what this script is doing is it's taking this first bit, this right here, velocity particle shape dot speed, and it's setting it equal to the magnitude. So that's just basically figuring out what the speed of the particle is. And then saying that if the speed is less than 15, then give the rate a value of 0. So anything slower than 15 units per whatever, give it a rate of 0. Otherwise, give the rate a value of 100. Okay? So again, this is something that we're going to punch in, but something very cool that allows us just that extra level of control. And we can even take this further and say, if the rate is less than 15, give it this. If it's between 15 and 20, give it this. If it's between 20 and 30, give it this. If it's between whatever and whatever, we can give it something else. Okay? So we start off with this little script. So I'm going to copy it. If you want, you can just type into Google.
Is that Mel?
No, Mel is something different. Mel is like the actual programming. This is kind of like just an expression, just like a little mini program. So we just go to Google and type in emit particle based on speed Maya, and the first one on CG Society is where that script lies. That way you can copy it and then you can paste it, as opposed to having to type it and then having a bunch of errors that I have to correct. Okay. So it's the one that's a bit down. It starts off with it's by Dr. Gonzo. There you go. Yeah, I just tried it. It seems to be working. Okay. So we copied that little bit of a script, and we're going to come into Maya, and we're going to apply it. Okay. Now, before we apply it, let me just jump back to the script again so we can see it. Is that this guy here, this velocity particle shape dot speed? This is the name of the particle shape. Okay, our particle shape is not called velocity particle shape. Ours is called probably particle shape 1. Okay, and then this dot speed, that's an attribute that currently does not exist on that particle shape. We have to add that in there so that it has somewhere to store that information. Okay, so we'll jump back to Maya. I'm going to grab my particle and scroll down to where it says per particle array attributes. And you should have an area at even below that that says add dynamic attribute, and we're going to hit the general button. Okay? When we get into doing stuff like sprites, or we get into doing stuff like instancing and a lot of other cool stuff, we'll use this window a lot more. There's actually a whole tab built for particles of all these different things that we can add to help control our particles and do different things to them. All right? But for now, we're just going to create one called speed. So just write speed up at the top. And because we're using this for particles, we want to create a per particle array. Okay? And what this does is it allows each particle to have its own value. So particle 1, its value can be 20, and particle 2, its value can be 30. If we don't click this button, then every particle has the same value. We don't want that. So per particle array, speed, hit OK. And so now we have this thing called speed right there. So we're going to right click next to speed and do a runtime expression before dynamics. All right, there's 3 different ways we can add an expression. One is at creation. Okay, creation is just like in the real world when you're born. The particle gets born, the first frame that it's on, it gets stuff applied to it. Okay, like I might say the second this particle is born, you're red or you're blue, and then I could say after or before dynamics or after dynamics, depending on which one works out better. I want you to change to purple. I want you to change to green. Okay, so right now we are having something that is running the entire time. So we're doing it before dynamics. We could also do it after dynamics, but I typically run things before. So we're just going to paste that script inside there. And we're going to change the names on things because our names are different than their names. So anywhere it says velocity particle shape, we are going to rename it. Our name is right here, particle shape 1. That's what mine's called. I'm sure yours is probably called the same thing. So we have to do, you can actually copy paste, Control C, and then Control V to paste those. There should be 3 spots that we have to change that on. Okay, and then we should be able to hit create, and then it should punch in and work. All right, so right now this is setting this up to be linked to emitter 1. And emitter 1 is not what we want. At least I don't think it is. I'm going to hit play just to verify. Yes, that's correct. Okay. So emitter 1 is this guy here, right there. So it's linking it to this. We don't want to use this. We want to use this guy here, fluid emitter 3 rate pp. Okay. So if we look inside this list of attributes, you'll see that there's one called fluid emitter 3 rate pp. So that's what we're going to type in. So we're going to emit the emitter 1, and we're going to type it in exactly as it shows it. And once you have it once, you can copy and paste it for the other one. We don't have to have the dot rate. There we go. We just type in fluid emitter 3 rate pp for both of those, and then hit good to go. There we go. This should work. This should be functioning exactly like we're figuring it should. And the fact that it's taken the magnitude, figuring out the velocity of each one, and assigning it to the speed variable. And then the speed variable, if it's less than 15, it's this. If it's greater than 15, it's that. Okay? So that is functioning correctly. So we have to do a little bit of diagnosing to figure out why it's not working. So the particles actually have tools that allow us to do that. So what we're going to do is on that particle shape, we're going to scroll up to where it says render attributes, and we're going to change it from points to numeric. Okay? By changing this from points to numeric, when we hit play, we'll see a whole bunch of numbers popping up. Okay? And these numbers, because the particles are on top of each other, they're actually a little bit hard to read because they're on top of each other. So I'm actually going to lower my emission rate to, let's say, 5. Should give me a good sample. There we go. And now you can see there's 1, 2, 3, 4, 5, 6. And then as they're moving. So by default, the particles, once I change them to numeric, they automatically get the particle number. Every particle has its own ID. 1, 2, 3, 4, 5, all the way up to however many particles you have. So I'm going to click on this current render type under the particle numeric. See where it says numeric? I click current render type. And again, a fun thing that Maya likes to do is when you click on something, sometimes it doesn't update the attribute editor. So then I hit select, and then it updates the attribute editor. So I'm just going to change this particle ID to say speed. Okay? The speed is that attribute that we created. We made a new particle attribute called speed. We assigned it the velocity. And now what we want to do is we want to read this speed value to see what each one is reading. Okay? So as I rewind this and hit play, you'll see that all of these have 0, 0, 0, 0. But right before they pop into 0, if I go frame by frame, we can see it, hopefully. There it is. You'll see that this one jumps to 658.172. Okay? Now, why is it jumping from 0 to 658.172? Any guesses?
This guy hit on the other side.
What was that?
This guy hit on the other side.
It's got what?
The ball hit the other side.
Right, it hasn't hit the other side though. We're only at frame 7,
Wow.
and the ball is way over there still.
Interaction between the shatter components?
Nope. Our goal, okay? That particle is just being created somewhere, and then in one frame, it's zipping over to that spot. Okay? So it's zipping at 658 miles per hour, basically. Okay? So what we have to do is... think about this for a second. Well, we can still work around this. I didn't have to do this step before when I did this, but we'll just do it anyway. Okay, so we're going to right click and go back to that runtime expression. Okay, so we just right click on the speed or the rate or any one of these things we've written the expression on and do the runtime before expression to get back in here. So what we're going to do is do a little expression before this particle shape 1 dot speed. Okay, so we're going to say if, and I'll actually type this out. Let me type it out and make sure it works, just so I have my stuff correctly, and then I'll copy and paste it. So I'm basically saying if the age of the particle is greater than 0.1, then go ahead and assign this velocity value. Otherwise, I'm going to set it to be 0. Haha, look at that. It doesn't happen that I type it correctly on the first try. Okay? And obviously, let me make sure it works first before we get too ahead of ourselves. Perfect. That's exactly what we want to happen. Okay. So what we're going to do is just change that first line. Instead of it just being this particle shape 1, is we're going to add this whole thing there. All right. This is part of the fun of using any kind of dynamic system, is that you run into these little random things and then you have to kind of troubleshoot it. So yeah. So we just wrote a little script and that figured it out. This other one that I was playing with, the goal U and goal V, sometimes that helps kind of figure out where the particles are being born from and where they go and all this. It didn't function correctly. Okay? So now, boom, it hits, and now we're actually emitting something. Okay? And then what's cool too is that once they stop, you can see down here, their speeds are at 0.193, 0.145. They're no longer emitting anything. All right? So we have basically total control over this entire feature of how often we want these particles to emit, okay? And it's simply a matter of going into that expression again and saying any particle that is moving less than, let's say, 2 units, whatever that speed happens to be. I'm sure it actually has a value, but it doesn't mean anything to us. All we know is it's 2. So there they're emitting, and if we watch it, you can see down here they're still at about 6 or 5. And now they're stopping emitting because they hit below that threshold of 2. Okay? As you get further into dynamics and you get further into adding these custom attributes, it's not uncommon for you to even create something out here if you're in my animation class, you've had the animation class, we talked about rigging. So a lot of times we'll actually have stuff out in the regular area where we can just manually type stuff in, and our expression will read from that. So it just makes it a lot easier, okay? So cool, that's wonderful. We can play with that again later if we want to. Mm-hmm. I have my box here, my fluid container, on this side, the watery side of this thing. You have it on the other side. You have it over there, okay? All right, so that's very cool. So now that we have something happening there, now we can exploit that a little bit more. So I can go into, now we have to think, because we've set up basically our building is emitting particles. Those particles are now emitting those other particles, so we have to kind of keep track of all of these things. It can get very complex. So I want to grab the building pieces that are emitting particles. So I want to grab the building emitter, and I want to turn that rate up. Okay, so I don't remember what I had yours set to, but I'm turning it up to about 100. Okay. That'll give me a good enough sampling now that as these things fall into it, that we have enough particles actually flying around the room. Okay? Now again, there's a lot of particles. It fills it up. It's a big smoke cloud. We can't see a thing. That means we have to make our box bigger and add some resolution to it. Okay? Because again, if we have a box this big and a particle just touches that box, boom, there's a voxel getting filled up. But if that voxel is that tiny and that particle just goes into that little area, then that voxel is just filled up a little bit. Okay? So we need the box to be a bit bigger, and we need our voxels to be a bit smaller. So we take our size of the box and just make it a bit bigger. So maybe like 130 that way, 80 and 80. Try that. And then I'll take my resolution up to 60 again to start. Okay. And now you should see that we have a much more controlled movement here. Okay. Now this smoke, the amount of smoke coming off of this, that's where we set this to be 100 in our expression. Okay. So each particle is emitting 100 fluid emission particle whatever things. Okay. Some of those, if you remember, we had particles stacked on top of particles stacked on top of particles. So each one of those areas is emitting 100. So there might be like 10 particles right here, each emitting 100. So that means that each one's emitting 1,000. Okay. So I'm going to go back to that expression. So I'm going to, once you get to this point, we actually have to go to the outliner to select the things we want to grab. And I'm going to grab the particles and go back to that expression and just change that rate. Instead of it being 100, maybe it's, I don't know, 15. Okay, don't hit enter, just hit edit after you've typed in that 15. Okay, so now that we have this, now we can go through and do the whole customizing of what the fluid looks like. Okay, for this fluid, we're not going to have a fiery center and then the black smoke going out of it. There's actually a video I watched that was really cool. It went into the science of how smoke gets colored based on the fire, and depending on how wet the fire is depending on what color the fire is, which is pretty interesting. In this, we're just going to do the artistic thing and just kind of figure out what we want it to look like. Okay, so oops, let me grab my cube here. Now we still can control, even without going to that expression, we can still can control how much particles are shooting out of this. If we go to that fluid emitter, this rate here, if it works the same way it worked before, shouldn't be doing anything. Okay, so setting that to 500 isn't doing anything for what is happening, how many particles are being emitted. Setting this to 0, you'll see also nothing is going to happen. Okay, this rate has now been Oops, I lied. It should have been overridden by the other one, if I'm remembering correctly. Maybe something changed. Doesn't matter, okay? So we can use this, I guess, as a multiplier to say we want this to be less. So we can set it to 2, and now less particles will come out of there, okay? So that was one way we can change how many particles come out. The other way is down here. This is the one I was going to show. Further down in each emitter, it's basically how much density, how much heat, and how much fuel is coming out of them. So when we talk about the temperature, and we're like, you know what, I really want that core to be super hot, or I really want that core to be super cold, or whatever it is, we can really crank this up and make that core super hot by cranking that heat up to 10. Okay? In this case, we don't even need the heat. We can just take the heat off and take the fuel off, and we could even cut the density if we wanted to cut the density. Okay? But as we know, we could also cut the density once we have it emitted. Okay? So I'm going to leave it at 1. It's actually at 0.5. It looks good at 0.5. So I'm going to leave it at 0.5. It looks nice like that. Okay? So now we can go into the fluid shape and just start to adjust the way this looks. So we're going to start at the top again and just work our way down. So the boundaries, again, I like to kind of turn the boundaries off. So no boundaries for any of these, with the exception of maybe the ground. But even that, I don't want that. If this was a flat ground and I had my particles, my smoke kind of coming and hitting the ground, I would have that bottom Y, if I can go in here and take the negative Y, that would actually be a boundary, so it would automatically collide with it. I wouldn't have to have a colliding object, okay? But I'm just going to leave it at none. Dynamic grid for density, dynamic grid for velocity. We're not going to use temperature in this one. This is simply just smoke and debris. That's all this one is. Let's go to not display. Yeah, display. And set this to voxel quality better. And we'll go down to dynamic simulation. And we'll take our high detail solve to all grids. Take the solver quality up to 25. Alright, we'll keep going down. If I go too fast, let me know. If you miss one, let me know. Here's where you can do liquids, just so you can see there's the tab for liquids. This auto resize one, just so we can kind of cover some of these, is pretty cool. If you have a character who's like on fire, and you want that character to run around the thing, and you don't want to have this huge container for this tiny character and this tiny fire, you can use auto resize. And what it does is it just fits the container to your object. Okay? So as your guy is running around, he has this container basically following him. So that's a kind of a neat way to do it. Again, it takes resources. For what we're doing here, it doesn't really make a whole lot of sense. We could, well, where'd the ball go? Wherever the ball went, oh, it's inside the collision. We could do that for the ball and turn the auto resize on and have it just kind of follow it. But that smoke trail is so big, it just makes sense to have it just wide open. Okay, so that's auto resize. Self-attraction is just self-attracting it. Here we go. Back to content details. We'll go to density. And we'll just start to play with this, okay, until we get it to look the way we want it to look. We're not dealing with temperature. We're only dealing with density at this point, okay? So we're just going to play with the settings until we get something that we like. So I want you to actually just go through the settings and just try to look at and remember from the first time what we did, and just mess with them and see if you can get something that looks like the kind of debris smoke you would want for this building to hit, and actually like smoke kind of lofting from it. You could even go to Google, obviously, and type in things. Building. Just look up any Michael Bay movie, you'll get lots of reference. There you go. So something like this, obviously, you kind of see the smoke in that one. This one's more of an explosion, it looks like. Of course, everyone remembers from not that long ago, 9/11. Not that you want to remember it too often, but lots of different images here that you can get different ideas for what that smoke would look like and what it would be doing. With this, I mean, it's so thick and turbulent, and there's a lot of stuff going on, so you kind of do your best to figure out what you want that to look like. We don't have a whole lot of resolution in this, again, right away, so we just do our best to kind of figure out what the dissipation would be, what the movement would be. You can crank these above what they're set to, so I can put this to 8, and that way when the thing actually hits, there you go. You can see it kind of wafting up like there's a breeze or something, like it's pushing it up. Okay? Or if this was some sort of fire, that fire would be driving the smoke upward as opposed to just going outward. Okay? So just take a few. Alright. So we can, again, play with these things a lot. The way you're going to learn this stuff is literally by just playing with it. In the future, when you're doing these things and you're trying to troubleshoot and trying to figure out what the best way to get it to look the way you want, don't change 6 things and then hit play. Change one thing and see what it does. You know, take the buoyancy up to like extremes. Like, I don't know what buoyancy does, so I'm going to make it 50. That way I know that when this thing hits, I can look at this thing and say, oh, okay, I can see what buoyancy does. It's literally how fast it moves upward. Okay, and then I can start to hone this back to a value that I like. Same thing with any of these. You know, I'll take the turbulence, even though the slider might only go to 1, I'll put it up to 30 or 100. And it'll really go crazy, but at least you get an idea of what it's doing, and it's not such a subtle effect. Okay, you can see right now. Look at that; it's just going crazy. It's just moving so fast; it's dissipating. So I can put that down to 2, put this swirl up, a little bit of noise. There we go. So now I have some pretty nice looking smoke. And again, I'm looking at this as a, what is this going to look like when it's finally done? I know that a lot of these areas, that smoke detail is going to be a lot more refined. Okay, so I always keep that in mind. And nothing is going to be, click a couple buttons and then you have smoke, or click a couple buttons you have fire. You have to put the time in to make it look correct. So we can come down to, just for fun again, there's a surface tab. And in here you can actually say surface render, and it'll render like blobs. So if you did want to do like some sort of liquidy thing, you can make it render like a surface. We're going to go down to shading. There we go. And we have some other things we can adjust. Here's the transparency. So if we realize we like the way the whole thing looks, but it's a little bit too transparent, we can adjust it, or not transparent enough. There's also a glow. So on that meteor that we had, before we rendered it, we would actually put the glow up a bit and add a little glow to that front. That way the front of that is really like glowing as it's hitting, kind of emphasizing the fire a little bit more. This drop-off shape, we don't really see it too much, but this cube actually has a drop-off, okay? It's basically when it gets close to that edge, it's just fading, all right? If the drop-off shape is gone, it's just going to disappear, and there will be no drop-off. Or if we make this bigger, like that, you can see the effect that it has, where now this cube shape, I'll even make it 10, oops, 5, 4, 2, 1. All right, you can see how it's dropping off and kind of fading and hiding some of this. So that's what that drop-off shape is how close it gets to the edge of that before it starts fading. So again, we can play with the coloring in this. Again, if I take this to, this, it might start reading from this incandescence. It shouldn't because it's such a temperature. But I can also add coloring inside here. Maybe I'll add a little brown. Some desaturated dark brown. There we go. And I can set this to density. And I can use my little slider to add a little bit of noise inside here so that I'm getting some gradations of color. So I'm not getting just beige or just black or just whatever. I've actually used this color swatch as a way to add some coloration to that smoke. I can also come down here to my opacity again and play with this. Slide that around. Right here under shading. Yep. Play with my density some to get that to look right. There's also a shading quality, which I could turn up to 2. And there's also a textures, which I could texture the color, texture the opacity. And these just allow just another level of detail to be added to it. So when you see something like, let me find a good, let me type something. Nope, I want spell right. Bomb. So when you see stuff like this, and there's all this detail inside that smoke, the FluidEffect is calculating most of that, and the other part of this is coming from these textures down here under shading and textures.
Did you notice it was a clown?
What?
The clown.
No, I didn't notice.
You don't see it?
That's his face?
It's his mouth go up.
Oh, I get it, yeah. That's funny. So again, we can play with these things inside here. It is going to render a little bit different when we hit the render button. So sometimes at this stage, we'll be rendering things out and taking a look at it. You can see that from my rendering, it looks kind of like, it looks like dirt. Doesn't really look fantastic. So I actually want to come down also to lighting and make sure that I have shadows on. Ooh, look how fancy that looks now. We have actual shadows. And that will, again, give us another level of detail added to this that we didn't have before. And once it's done rendering, I'll scoot it over to the other screen. Or maybe it'll jump. Nope, it didn't jump. Okay. So now you can see here, now we have just another level. I always turn around and then you can't see anything. There you go. So now you can see a little bit better. Another level of detail inside here. Another level of, something else is happening inside this to give it a little bit more stuff happening. Okay? So all of these things you can play with as you're working on yours in order for you to get it to look like falling debris or smoke or any of this stuff. Okay? All right, so that's it for that specific one. Again, before I would actually render this guy, I would take that base resolution and just crank it up to 120 or whatever. I'd start off at 100 probably, test it out and see. I would also do a play blast. So everything we do play blasts. And I hit the wrong button. I want to do a play blast, but not that kind. I'm stuck with it now. QuickTime H.263 from Windows, scale it to 1, and then play blast. And then this will give you a real-time playback of what it's going to look like. That way you know, wow, my smoke is really flying, okay? We have to think of the scale of this. If this is an actual building getting demolished, the smoke is going to move differently than if it was my pop bottle getting demolished, okay? So you just have to consider that as you do it. So we hit play blast, we watch it. It's typically the workflow for me is that I hit the, for stuff like Bifrost, you hit the play button and let it simulate all the way through. When it's done simulating, you hit play blast and let it simulate all the way through and give you something you can actually watch. With FluidEffects, we can just hit play blast and it'll calculate and give us that real-time playback, okay, once it's done.
So can those be cached as well?
We would cache it after we're satisfied with it. Yes. Okay.
A limbic cache or no? Fluid
No, we would do a fluid cache, and we would also. I just had it. We would also want to make sure. Right now, the building pieces are not colliding with the fluid. Wow, that is a horrible.
Beautiful.
Yeah. Well, at least we can look at the speed. That's really what we're gauging here. Yeah, the speed works pretty good. I mean, it looks kind of like it dissipates a little bit too quickly and, hangs out for a little bit too long. We can adjust that. But the building pieces are also not colliding with this. and that would be a good effect, okay? Because what's happening is the building piece is falling, and the smoke is just going right through that building piece as it falls. It'd be nice to have it wrap around that building piece. It would look a lot more realistic. Okay, we can get that too just by grabbing the building, shift-click the container, and saying Fluid Effects, add, make collide. There we go. Okay, so make it collide, then we're going to do one more thing, and then I'm going to let you, on your own to play with these. You can see that we actually get a little bit different results because they're colliding. The fluid effect is not as much because now they're kind of pushing into each other. Okay, so then again, I would have to go through and up those settings. The other thing I want to do is I hate doing this, where I hit the play button and I have to wait for all of these particles to load here, and they're still loading and calculating as we go. What I want to do is I hit play, I calculate however many particles, 1,000 particles in there, and then they just are there for the rest of the thing. Okay? So we're going to grab the building solver, grab that emitter, and we're going to emit Omni 1. I'm verifying that this works first. There we go. Okay, so if I do Omni 1, you'll see that this basically it populates a particle everywhere, right? Just like we talked about, every single point is going to be on there. It doesn't happen until frame 29 though. Okay, and the reason that it happens like that is because we're doing one particle per second, and it just happens to wait until the very last frame to do that. So if I set this to be 29, and I hit the play button or the advanced frame button, you'll see that by frame 2, they're already there, right? So what if I just set this to frame to 29, and then I turn it right off? So at frame 2, that's at 29. At frame 3, it's 0. So now the entire building gets the particles, and now they're just gone. Okay, they just hide. So I'm going to go to frame 2. I've set that to 29. I right-click and key it. I go to the next frame, turn it off, and key it again. So now if I hit play, there they are. And then my ball comes and hits it, and then everything interacts correctly. I could even set this to be like 0.5. I can't set it to 0.5. Okay, now I can also do this. I'm done with that, the speed of those. I can just turn that off. Just go back to my particles and set the particle type to point. There we go. And I also need to add those to a layer. If I render this through mental ray, I'll actually see the points. So I add those to a layer and just hide it. Okay. So now we have this interacting correctly. We have every single piece has a particle on it, and then every single piece is emitting based on their speed. Look at that. That looks beautiful. We just need a little bit more fluid smoke inside here. I also need to make the container probably a little bit bigger to encase all of this. Your first one that you had where it exploded,
Yeah.
you would have to have a huge container to house all that stuff. Okay, so with this smaller one, I'm still pretty good. So I can just take this and maybe make that 130. It looks like it's stretching it, but it's not. So rewind it. I would again take my resolution up to 100. I would hit play and just let it calculate. Just let it do its thing and figure out what it's going to look like. Now again, it helps to have a book or helps to have something on hand where you can just, learn something and not just staring at the screen for 6 hours. Or if you have the Maya help up, you can look through these types of things here, and it also helps somewhere in here. Somewhere inside of this, I don't know where exactly, they actually have, like, it walks you through how to do some particle things, how to do some fluid things. And this is from Autodesk. Let's probably just type in Autodesk after this. There we go. So it also helps you just kind of walk through some of these other ones and just see, you know, what are different ways you can approach it. We're using 3D fluid effects. There's actually 2D fluid effects. So if I just had a character and I just wanted an explosion to happen, I don't need to be able to like whip around it. I can just do a 2D effect. Obviously that would be a lot quicker. Okay? Yeah, that's looking pretty good. So there's lots of different things that we can play with fluid effects, lots of different things that we can utilize. If you're taking what we've done here and now you're going to apply it to your scene, okay? If you have Bifrost, obviously turn Bifrost off and hide Bifrost before you do any of this stuff. But you want to have this thing just kind of as quick as we were working today, getting it all set up and then cranking up your settings. Even at this thing being at 100, it wasn't terrible. It was you know, manageable. Some of these will actually go up to 200 or 300 depending on how detailed you need that solve to be. Once you have both of these set up and ready to go, like this guy's ready at 250, let's say, and this guy's ready at 100, individually we would create a cache, okay? Just like we did for Bullet and for Bifrost, but it's going to create the cache right inside the file so that it's not going to be like an external, like a Limbic file that we would be loading in. So we would just call this whatever it is. Let me make sure I disabled this one, yes. Okay. So this one is my building smoke, so I would just say building smoke. I like to do one file per frame, that way in case something crashes, we don't lose everything. And then the time slider is typically what we have that set to, and then create. And then it's going to go through and it's going to write out all that data. So again, I'll be able to click in here and drag and it won't, you know, freak out like it probably would do now. So we do that to that one, I disable it. I click on this guy, I do a cache on that one, disable it. Okay, and then we can move on to the next stages of doing a final render. For the next stage of this, you're going to do a regular render without any passes, without anything fancy. Okay, so the goal is for next week is that you have your building with the smoke being hit and you've rendered it out so you have a movie. When you come in next week, we're going to go through the process of taking what we have. So far we have the building being knocked down. We'll have the smoke in there. If you have Bifrost, I'll show that as well. And how do we separate these things into elements? Okay, because what we don't want to happen is we render it out and we're like, ooh, the smoke is just a little bit too brown. I need it to be a little bit blacker, or I need this and that. You can't edit those things in post unless you've separated all those elements. Okay, so next week that's what we're going to be doing, is breaking apart all this stuff. All right, so that's fluid effects. That's as far as we're getting with fluid effects for this